Good afternoon and welcome to today's panel debate on should your data be relational. Today I'm joined by Stewart, Lucas, and Heli, three experts in the field. My name is Neil Mendelson. I'm a product manager in our database development group. And let me turn it over to Stewart to introduce himself, and then we'll go on to Lucas and then Heli. Stewart.
Thanks, Neil. My name's Stewart Bryson. I'm CEO of Red Pill Analytics, also the founder. I'm an Oracle ACE director, have been for many years, and also an Oracle Groundbreaker ambassador. I'm really honored to share the screen with these two distinguished speakers, and I'm sure very competent debaters.
Heli?
So I'm Heli Helskyaho. People know me as Heli from Finland because I do come from Finland and my last name is impossible. I'm a CEO for Oracle Finland, which is a small consulting company in Finland, Oracle ACE director, Oracle Groundbreaker ambassador, a data person. I've been using Oracle since 1990 or so, and I've been doing everything.
All righty, and Lucas?
Hi, my name is Lucas Jellema. I'm from the Netherlands, CTO with Amis, a 30-year Oracle partner from the Netherlands. When I go to customers, I would call myself cloud solution architect, but at heart, I'm still very much a programmer. And like the previous two speakers, I'm a Groundbreaker ambassador, Oracle ACE director. We know each other very well, so even though it might get fierce at times, we are really friends.
All right. Well, let's start this off with Heli. And Heli, could you define from your perspective, what is relational?
My pleasure. So those who don't know history are doomed to repeat it. So let's start with the history. So we did have hierarchical and we did have network databases, but the revolution started with a guy called Edgar Frank Cott. We know him as Ted Cott. 1969, actually quite accurate, 51 years ago, he published a famous paper about relational model. It was not just yet another data model. It was really something new because it makes database management into science, providing a theoretical framework for that. So the relational model really serves as the basis for a theory of data. It's completely based on math, set theory, relational algebra, logic. And by the way, in relational model, the word relational has nothing to do with the R in ER diagram, entity relationship diagram. It's not relationship. It means actually mathematical concept, unary relational in set theory. So it's from set theory. So everything is from math. The predicates to guard the data from tuple level to see what kind of data you're allowed to have in a tuple, in an attribute, in a row in a table, and so on. Table level to make sure that your table has correct data, including primary key. Database level to ensure that the data in your database is correct, including foreign keys. Then operations to tables like unions, intersections, difference, projection, joins, aggregations, all these kind of things. This is not the first debate about this topic, by the way. 1974, there was the great debate when the relational model was against network model. So this is old thing also. Actually, so what Cott did, he was not alone. 1970, around that time, C.J. Date, a mathematician, joined his team. And actually, in 1975, he published his famous book, An Introduction to Database Systems. And at least for me, that was the book to teach what relational model is about. The biggest problem with the relational model is that people don't really understand it. And I would really like to blame Cott himself for it because he announced it in his different papers and books in a different way and people got confused. The third manifesto, 1995 by Darwin and Date, you can read about it, thethirdmanifesto.com, was an attempt to try to explain it one more time. I hope it helps, go and read. 1981, Cott got the ACM Turing Award, which is a great achievement. So if this does not convince you about relational models' explicit uniqueness, nothing can do it. A lot of people think that relational model is equal to SQL, which is not true. SQL is a query language, just the one that won the competition. There were other options as well. So it is not the relational model, it's just a query language. And actually 1986 was the first time that we had a standard for SQL. That's much, much later from 1969. So after the model, we have the implementation. And this is where we can actually fail totally. It depends on the relational database management system, how well it actually implements this theory And that's why we have big differences between different databases. And another thing is the database design, how well the database has been designed for a relational model. So a database system is relational if and only if the user interface it supports is faithful to implementation of the relational model, meaning that the data looks relational, tables, columns, rows, primary keys, foreign keys, all that kind of stuff, and relational operators such as joins are available. Then we could talk about relational model.
Alrighty, well, thanks for that background. So this morning, Juan introduced the new autonomous JSON database as a new offering. So let's get right into it. JSON is another example, very, very popular with developers. Lucas, if relational has all this history and background, is that kind of old news and JSON is the new news? Give us your perspective.
Well, JSON is completely different from what Heli just described. JSON came about in a very pragmatic way, almost accidental way. It stands for JavaScript Object Notation. It's a serialization format for data that's in memory in a JavaScript application and that we want to write out to disk. It happens to be human readable, it happens to be very compact, and it happens to be very easily processable in JavaScript and also in several other programming languages. And that made it very popular, especially for using it as a transport format for data flowing from backend systems to web applications or mobile applications. Data that could be transferred and manipulated and handled very easily on those client applications. And then, of course, it became interesting in cases where both the front-end application and the backend system could deal with JSON to not any longer use relational data as your source for the JSON data that eventually you're going to provide to the web application, but to store it as JSON formatted data, because that's much easier to handle and to provide.
Now, so Lucas, you have a lot of experience in your background, right? Having written applications using relational technology and then over the last number of years from a JSON point of view. So if you're going to start off writing a OLTP type application, are you going to start with relational or are you going to start with JSON?
Since you specifically mention OLTP, I'm assuming that transactions are important, and in those circumstances, I would still go for I would just pick a relational database. I might then complement it with other solutions, NoSQL solutions, maybe JSON-based solutions. For example, at the moment, one of my projects is building an IoT platform, an Internet of Things platform, where we gather data from devices in the field. All these devices, edge devices, very small devices, they send messages to us, to our platform via MQTT in JSON format. We process the data in JSON and we provide the data in JSON to our end consumers. It doesn't make sense for us to store the data in anything but JSON because there's no reason to handle it in any other way than JSON. However, the metadata about all these devices that's stored in a relational database.
So Heli, let's come back to you for a minute. So what Lucas said was he's going to store the metadata in relational, but he's going to have the transactional information in JSON. Would you do that, or would you do both in relational, and if so, why?
I might do it if I have converged database available, but if I have to use two separate products, like if I would use Mongo for the JSON part and then let's say Oracle for the relational, no way, then I would just put everything in relational. But if I had converged, yes, why not? But I think the idea is that you have to understand what you're going to do with the data. So if you don't know that, then relational is the safe option for everything. But if you know what you're going to do, then you understand these differentiations, then it's okay to use JSON, but you have to know, you have to be educated.
What's the benefit of converged, right? If you're saying that, if it was in a converged database, right, you would use JSON and leverage relational,
Plenty of benefits. First of all, I would have everything in one place. I would be able to have a backup of my system, which is very important. I want to have backup and recovery of the same exact moment. And secondly, if I come to second thoughts, I really want to use the JSON as relational, I can do that easily with Oracle's converged database. So being able to handle different kind of data models and converting them to other models, either permanently or just in memory, is a fantastic thing to have. Just to fix my, probably make a mistake on how to use the data. Or maybe the world changed and I want to use it in a different way and I need different kind of data model for that.
Okay. Now, Stewart, you're an expert on that from the analytics point of view. Lucas talked about from a transactional point of view, and Heli as well. From your perspective, from an analytical point of view, where does JSON fit in? Where does relational fit in? What are your thoughts?
I think relational will always fit in for literal transactions. And I mean transactions in the real world, right? Not necessarily database transactions. So financial transactions, those sorts of things, relational is always going to thrive there. However, the application that Lucas described, in my mind, does not need a relational model in it at all, right? Because you think about the one thing he was storing was metrics. Sorry, Lucas, I haven't taken a close look at your application. So all I can say is from a high level perspective. I mean, events are what happened in the world. The world doesn't contain tables, columns, and rows. It contains events. And developers want to model events. They want to model objects. They want to represent those objects. If the application is bringing in events, if the application is producing events, and everywhere in between are events and objects, perhaps the relational model is a distraction. Developers will have to maintain that ORD system, that persistence layer, that translation from object to relational. And that means that they're normalizing these structures out from events. And I can tell you from an analytics perspective, what we do, a good portion of what we do is data engineering, modeling this data and engineering it into a usable format. And we often have to reconstruct these events, these objects from these relational models. If I can consume JSON as an event, and I can process that in a streaming framework, and that streaming framework can respond to events, then that's really perfect for me, because I don't have to go back to the source system developers. I don't have to go back to the data modelers from the source system and ask them how to reconstruct these events. I simply consume them. And that payload is typically JSON. I can serialize that to other JSON adjacent languages like Orc, Parquet, Avro, other languages that have a similar mentality to JSON but are just more performant for analytics. I can serialize those things and store them. And now when you look at distributed data platforms in the cloud, we can store those open formats in buckets normally, right? This began in Hadoop, but it's moved to the object store. There are lots and lots of frameworks that can all process those open data formats. So you have your options.
And do you have a language of choice for processing those data elements?
Yeah, it's usually Spark. You have to say why not Spark in a lot of cases, but there are great streams. If you're using Kafka as your ingestion platform, you might look at Kafka Streams or KSQL. Spark also has Spark SQL. So tables, columns, rows, as Heli mentioned, I can do all of that when my underlying data is JSON, Avro, Parquet, any of those relational formats in a distributed data platform.
So earlier, what Heli said was that relational and SQL, people pair together, but they really are separate constructs, right? And what I hear you saying is that you're saying that, that these things are in fact different, and you can still use SQL over these other formats as you have been before.
Absolutely. What's interesting about the distributed data platforms that began with big data and Hadoop is they ran away from SQL as fast as they could, and then they all struggled to get it back in. And all of these distributed data platforms are all SQL again. What I would say, just the point I'm making to Heli is that when she describes a relational as tables, columns, rows, and I know she means more than that, right? She mentioned constraints and normalization, I believe. But if tables, columns, and rows are the things that you really need, and from an analytics perspective, that's what I'm most interested in, any of these data structures can work in any of these distributed data platforms when the underlying data is JSON or JSON derivative languages.
But the essence, and I think the essence was maybe captured by Heli in the way she described the relational model. The essence, I think, is the metadata, the description of your data, the data structure. You need to know extremely well what the data that you have represents, what rules it lives by, and that applies to relational data. And then you get it out of the box, but it also applies to JSON and the other formats that you were mentioning. And if you don't have a very good
Metastore, right?
The definition of the data, then you're nowhere, regardless of the format.
Most of these distributed data platforms use the Hive Metastore. There's other, Presto's a good option. We aren't just querying files with no definition or description. It's not what we're used to in something like an Oracle database where the SQL parsing language is tightly coupled with
The structure.
with the structure. But we do register going in and out of these data platforms. We do register our schema on the way in. And so there is a place, usually by a REST API call, to get the structure of the schema, and application developers can use that. And often it's versioned over time.
You mentioned like normalization is a bad thing. That's actually a very good thing to guarantee your data quality. That's why we want to normalize, to be sure the data is correct.
Yeah, so normalization's been around for a long time. Now I'm an analytics person, so the normalization doesn't quite mean as much to me as it does to you. We typically turn off a lot of that normalization.
Because you come after the transactions.
Because you don't understand the relational model. That's the thing. That comes from the set theory and so on. So all this guarantees the good quality of data. And the idea is to store the data in a good way and then use it in whatever way you want to use, in whatever data format you want to use it. But to make sure that the data that is stored is good quality.
But if that normalization is, if we're normalizing a payload that's JSON, in Lucas's example from the top of the recording, or the top of the, sorry, this is live, from the top of the session.
You may be live, I'm not.
If we use that example, right, and we serialize it and deserialize it in and out of a relational model just to reconstruct the same JSON objects again, or the same, I don't care if they're JSON, the same objects or entities or events, what is the value of that? If we have to serialize and deserialize over and over again to produce the same objects that came in, then that's a performance hit. That is a performance overhead. If I can simply store that document, that entity, that object, to make it available if the consumers and the producers are all talking JSON, you've introduced an unnecessary layer.
So one of the things that we heard on this morning was, this notion of an autonomous JSON database, which essentially presents a complete JSON point of view to the developers, right? But also gives the ability to do SQL on top of that, right? So to you, Heli mentioned earlier this converged database. Do you also see this as a specific advantage to you? Because you don't have to serialize and deserialize, as you described a moment ago, within what Juan announced this morning.
Is that to me or to Heli? Sorry.
Why don't you pick it up?
All right. So I don't see really where that helps. If I can store the object, and this might be my lack of understanding of the product, right? So if I can store the object, that doesn't help me because I still have to normalize it out of that payload, right? Just the fact that I can store the object, the entity, the event, in the same database as the place where I normalize it out to a relational structure doesn't give me a lot of value, right? Developers want APIs. I like this announcement. The developer wants an API to be able to use to register an object, to get an object, put an object, those sorts of things. There are a lot of developers that don't see the need for relational models. Heli would probably school them and explain to them why they needed it. But at the end of the day, developers should be able to do what makes them productive, what makes them useful, what makes them generate content quickly. And from an idealistic perspective, if there's no transactions, if there's no financial transactions, if we're doing page rankings and cohort network and graph analysis, if those are the sorts of things that we're doing, then there's no reason to put a relational model underneath that. It slows us down. It makes us not. Yeah.
This morning, the announcement was really all about, the bringing people aware of the fact that the Oracle database can operate in a pure JSON mode, right? So you don't have to deal with anything other than gets and puts, right? You don't have to create, a single schema, right, that developers can't change, right, which is part of why they love JSON. So, for this sounds like an ideal thing as you were describing it.
Absolutely.
Okay. So why don't we move on, if you will, to the next topic and really ask ourselves, does any of this really matter, right? I mean, we talk about relational, we went through the NoSQL time, now SQL is back, now we're on to JSON. Does this really matter for the future? Or are we moving beyond these, format arguments?
It does matter because the data is there forever. Like I said, relational has been there 51 years. So there might be databases that are quite old already, and the data is there. They want to use the data. So you can change the interface, the user interface, to another technology whenever you want to, but changing the database is quite difficult because of the data. It's already stored somewhere. So how do you convert it to another kind of database if needed?
Isn't it quite difficult because it's stored relationally?
No.
I mean, what's been happening now in the era of the cloud is that people are offloading data from their transactional systems. Their transactional systems often don't store history. They're offloading that into cloud object stores, calling those data lakes, raw data, whatever. And they're storing it in JSON. They're storing it in Avro, Parquet, Orc, whatever. But they're basically similar concepts, right? They're offloading it and they're using that to reload or first time load downstream systems. Some of those are analytics, we do a lot of that, but some of those are just for, relational databases aren't great for search. So they use that to load downstream search mechanisms. So the opposite of what you're describing, Heli, is what's going on. People are offloading data from those relational databases into JSON format, into object storage.
And the reason is that because they don't understand the relational model and the relational database. So they don't know how to use it. And the reason for that is that. And then they take it to another place, which will actually hit us in less than 5 years, when they realize that the data they have now is not as good as it used to be. Because
their data lake's older than 5 years, and then they haven't experienced those issues.
No, they will realize it soon enough. Let's say that. It depends how they are using the data. But anyway, the point is that when you store the data, that's the thing. It should be stored in a way that it can be used for whatever technology. If you store it in the specific technology, you cannot use it with the others, unless it's a database that understands different data models and can convert them. Then it's possible.
And that's what you refer to as the converged database, one that essentially can store, a JSON object in its native form, to be able to store tables and with columns and rows in their native form, but to be able to interpret it, right, in a common way.
Exactly.
Lucas, what are your thoughts?
Well, what I'm seeing is that now we are designing and building cloud native applications, typically with a microservices architecture. Each microservice is its own standalone domain with its own data. And within a microservice, we can use one or maybe even different data storage solutions that could include relational, could also include JSON or other solutions. And what I'm seeing is that by leveraging managed cloud services, I don't really care all that much any longer about what's underneath. I talk to generic APIs, and sure, I still need to define the data structures, and I think we all agree on that the structure of the data, the metadata of your data is extremely important, but it can translate to different implementations. And I think with the Oracle Autonomous JSON service in addition to the transaction service and the data warehouse platform, you have different managed services that I can engage in my microservices, and I don't need to care about backup and recovery. I don't need to care about scaling and availability. And that, as a cloud solution architect, is what I prefer to have: the ability to use different tools for different use cases.
Well, this is, you branched into yet another kind of controversial topic, which is, should every container have its own database, or should you, does that lead to chaos, right? So
it doesn't necessarily need to have its own physical database. It certainly needs to have its own logical standalone data partition or isolated area, whether or not for practical reasons it makes sense to have as a physical instance a single instance that supports multiple microservices. I don't really care all that much, although I do want independence for each of my teams.
So it sounds like you're describing what Oracle and some others have done, which gives you the ability to essentially have that degree of isolation without separating it into completely different data stores.
That could work, although still separating it out into completely different engines might also work. We are no longer talking about this massive central enterprise database that contains all data for all applications in our entire organization. That's what we used to have in the 90s. That we are still seeing it to some degree, but I think we are moving away from that and isolating data that doesn't need to interact with data from other departments, other divisions, other domains.
Right. At the very least, we need to, because of various privacy laws and data protection, in some cases, that's, we can't have, all customers from around the world be in the same database, because, that doesn't respect the national boundaries in terms of.
And that's yet another consideration. Yeah.
Right. But for that, we have other solutions like sharding and other things like that to be able to handle it. So, Heli, why don't you try to bring us home here in terms of your closing remarks, in terms of what do you think, just summarize your feelings related to this, and then we'll move to Stewart and Lucas and then close up.
Okay, so I think it all starts with the requirements. So what are you going to do with your data? That actually is the whole key here. So what are you going to do with the data? Then do you understand the possible solutions? And do you understand which one is the best for that purpose? If you don't, relational is always a solution. If you do, then choose the one that is best for that purpose. But don't choose something because somebody says this is good, because his or her use case might have been very different than yours. And maybe this solution is not for you.
So make your own decision. Don't always just follow the crowd.
Yes.
Right? Aimlessly. Okay. Stewart?
Yeah, I would say, Lucas has got me thinking about microservices, and monoliths are dead. I didn't kill them. They've been dying for a while.
They've just become smaller.
Yeah, exactly. And as he was talking about the one of the biggest problems with untangling monoliths is this shared data structure, and the ability for smaller applications to own the domain of their data, use whatever API service they're interested in, SQL, Json, whatever, build that application in the way that makes sense. And in a cloud native world, all of these services using the same cloud vendor, triggers events, and we can respond to those events from a cloud perspective, pub sub type and streaming technologies. And we can listen to all these events, and we can tie them together downstream if we want to. So the idea that we have to store it, the first place we store it needs to be a shared structure of some kind, is actually antithetical to the movement to cloud native. So what I would say is build whatever works for you. We'll tie it together in the end in a cloud infrastructure.
And Lucas, you want to give us your final thoughts?
I think both Heli and Stewart did an excellent job in summarizing my thoughts as well. There's maybe one thing I would like to add. backend for front end, don't hesitate to create a read-only copy of your data for a specific purpose. That isn't harmful. We've done materialized views, we've done data warehouses. This could be just an extension in a JSON format for a JSON application. That might be a big help in terms of performance and development productivity.
Great. Well, I want to thank our panelists, Stewart, Heli, and Lucas. And for those that are hanging on, still with us, up next in the agenda is a number of hands-on labs. If you've pre-registered for these labs, then you can directly access them yourself. One building microservices that we referred to, and another one looking at the new JSON capabilities. If by chance you haven't pre-registered and you missed that opportunity, no worry. You can go to this URL that's listed here, and we'll publish that, where you can go into the hands-on labs and do your own self-guided lab. Before we leave today, we'd just like to get your feedback to understand how we did. So let's bring up the poll and let's ask the question. On a scale of 1 to 10, where 10 is the highest, how likely are you to recommend this debate to a friend or a colleague? So was this interesting for you? And if so, would you recommend it? Let's start the voting now.